All right. So good afternoon, everybody. I'm Matheus Merieri. I'm a senior researcher at YouKnowWatt. I'm going to give you a brief description of what we do, and this is going to be a physicist presentation, where I am the physicist, actually. And what this means is I'm going to go more into the technical details of how we do our NILM job, rather than on the commercial details. So we are quite a young company. We actually are a spin-off from the University of Brussels. So at the basis of our experience, there's a PhD thesis that's been completed at the ULB, in the University of Brussels, which then became a company. We're based in Brussels at an incubator, and as I think most of the companies in the NILM field, we actually had to start to do it all, to design from sensor to disaggregation algorithm to visualization of the data and the results. But our core business, what we really do is the disaggregation part. So we would gladly leave sensors to other people, other companies to build them and design them in agreement with us. We would gladly take the back seat and just provide some company the data to show to their clients what is aggregation. But what we really focus on is the disaggregation job, which for us it's event-based, and it always goes event detection, event characterization, pairing of events, and then appliance identification. So the title of the talk is High Resolution, Low Hassle. What do I mean by this? Well, high resolution is easy. We measure current and voltage at 1600 Hertz. Because we want to have as much detail as possible on the event that we detect. So this resolution allows us to both find out the transient shape of the events, characterize quite well the harmonic consumption of the event we detect, and try as much as possible to separate events that at a lower resolution would appear simultaneous. And what this enables us to do, since we have this many details, this allows us to not to hassle our clients and not ask for details about, hey, did you by any chance just turn on your A dryer? Or please, when you install our sensor, please turn on off the washing machine 5 times. We just have someone put the sensor in the electric switchboard. Maybe, if you have time, just ask for a list of appliances in your home so that we know what we're looking for. But even without that, we can work with it. And we just quietly process the data and put the results on the website for the client to see. Now, the only hassle that actually can come out of having a higher resolution detection is higher resolution means a lot of data, means a lot of bandwidth needed on the client's internet to actually send the data home for us to analyze. And this is why we're also rolling out some sensors that do a pre-processing on the premises, so that they don't send data all the time, they only send data to us when there's something relevant that happens. So from a theoretical point of view, I think the approach that we use is quite, true and tested. We have the 3 phases. We have the first phase, of course, is the event detection, where we try to find out whenever there is a change in the global state of the installation, a change in the consumption. And once we isolate, we can isolate with high precision where the events are. And then we go look really at the harmonic contact of the current rays. We characterize each event in terms of what changes has brought to the global consumption state of the installation. And once you do that, once you have a collection over a certain amount of time of events and their features, then you start doing the pairing, which is basically just saying, okay, this event we saw, and it's a non-event, goes with this event. and that's a non-event, an off event. And this allows us to get timing, to get frequency of how many times certain appliances switch on and off. And of course, once you have events, you have the pairs, you have the characteristics, you have the timings, you're ready to apply some rules to really identify the appliances that are present within a certain period. Okay, so this is the theoretical way how we envision our process. What we really do it, I'm going to show you what really happens to data from the installation to the end results. So as I said, we had in the beginning to develop everything, including, you see at the top of the slide, a sensor that we designed that continuously sends at 1600 Hertz, and this sensor sends to our router, which is actually a modified media hub that takes care of providing the Wi-Fi for the sensor to send, then connecting to the client's internet and send home the consumption data. Or, as in the bottom slide, as in the bottom part of the slide, we also have defined some, let's say, minimum criteria that a sensor should satisfy, and if your sensor satisfies that criteria, we're happy to work with it. If it has at least fairly high resolution, I would say, and if it can output its data in a certain format, we're happy to take it and to run our disaggregation on it. And in the picture, you see a sensor developed by Fluxo, which is a Belgian company. And then once the data is on the fly, this is what happens. So if you're familiar with big data technologies, you're going to recognize all the names on the slide. This is because this is, again, you go with higher resolution, you get a lot of data, you need to prepare a system that can scale whenever you get what you hope for, which is a lot of clients, a lot of sensors sending data home. So the idea basically is the sensor sends all the data on a queue, on a RabbitMQ queue, not a queue, or an MQTT broker. Then we have a streaming job that in real time reads the raw data of the queue, calculates the power in real time, and stores the raw data. And we use HBase for that. And then each night, a bit after midnight, we run a batch job that takes a look at the previous days or all the days that are missing from the processing, and does all the processing, does event detection, characterization, pairing, finds out what has happened during that day, and stores the results into our result database, which is MongoDB. And then from there, we can just pick out the data through our API and visualize them and provide them to whoever needs it. This is what works for us as of now for as a user interface. So you can select a period, which can go from a couple of days to a month or more. You can have a zoom in here in the bottom part of the slide. You get a pie chart with the energy total consumption disaggregation, and of course you get the list of the appliances. So this is one test we did, not the test with EPRI, but a previous test that we did with Bosch, in collaboration with Bosch. And yeah, so you get both in relative terms, because sometimes you need to know what is my biggest consumption. Sometimes you just need how many kilowatts my washing machine is doing. So I think it's actually all, because from a technical point of view, this is what I would consider most important. So on behalf of the team that's in Brussels, thank you for having us today. And if you pass by Brussels, drop us a visit. We would appreciate it.
Thank you.